I did it right.
So what I understand is there's three of us. There's myself, there's Mark Krotek, and there's David Boone. And what I understand is David has a teaching commitment at 11, but he's also slated to participate in the afternoon. So what I understand is I'll start, and then we'll move into Mark's discussion, if that's okay.
Perfect.
But first, I need to say thank you so much to organizing this. I think I learn something every time I hear Chuck or Janet or Becky or David Boone talk. Every time I interact with these people, Mark Krotek's my secret weapon. I always get so much when I talk to people at the science fair and when I connect with people. So bringing all my favorite people together on a Monday morning is like my dream, but thank you. And I think what the plan is for us to talk about how we teach. What you're going to see is that how, student research, I mean, the operative word for me is student, and it's all about, for me, is building relationships with students, because you work hard for the teachers that inspire you, and you shut down for a lot of others. So I think what you're going to hear is three different perspectives on how we have a personal journey of setting up our framework for working successfully with students. And I ask that if you find something that is good, take it. If you find something that sounds horrible, just leave it. Don't worry about it. You don't have to take it. And I would hope that at some point we all are, it's not just us talking, but that it becomes more of a group, organized group effort. And something I've noticed is that Nikki is the master at setting up the internet, the web page. Maybe there's some way we can organize ourselves to be more of a support group for one another, and to be a more organized effort as we're putting out our, helping our students learn about research. And I've noticed across the country and also around the world that there are lots of examples of resource centers and organized groups of high school teachers that help students learn about research and help them open doors. So that being said, if somebody has a question, I mean, you can put your question in chat. I might not see it because I'll be distracted, or you can also just interrupt, or have Nikki interrupt me and ask your question, or have Chuck interrupt. He's I'll say no more. Okay. All right.
Oh,
All right. So I'm going to talk to you a little bit. Actually, I timed it. It's a little bit about my research class. So I'm going to tell you, it's turned into a class, but it started as a group, and I have been teaching students the research process for about 15 years now, and it's turned into a class, an actual class in my school. But it's been a bit of a process. So I'm going to start first, though, by telling you a little bit about my personal journey. And the reason why I'm telling you about my journey is because it shows that two things came out of this journey. First is that an early research experience is very powerful. Nikki, can you mute Chuck? Thanks. All right, sorry. But an early research experience is very powerful. I started doing research when I was 16. And secondly, by seeing people that look like you is also very important. So I'm just going to take a few minutes to show you my personal journey and why I got into this in the first place. But this is me in high school in the 70s. In my high school had a science club run by a teacher. There's me. But my head was entirely focused on this young lady because she was appearing in National Geographic at the time. And I mean, when someone looks like you, I'm going to tell you, I was determined to be a naturalist. I was going to be a naturalist and a scientist. And that was my full focus. And luckily, I grew up in Chicago. My school was close to the Cook County Forest Preserve, so I wandered, much to my parents' chagrin. I wandered throughout the woods and did a lot of observing. And also my school was adjacent to the Chicago Zoo. On Tuesdays, it was free. So I would be there with my notebooks, my binoculars, my camera. I was observing every animal in that zoo. And I mean, it got to where I actually dropped my notebook one time into the moat that was, the Arctic foxes peed all over them, and my locker smelled like a zoo. But I was there every Tuesday, faithfully taking notes and learning about animals. And I got into college, and I just had to get away from high school because it was the 70s. They didn't think that girls should even take advanced science classes in my school. And so luckily I got into University of Chicago very young. I was 15, and I made a pact with myself that I was going to be in a research lab every year. So each year I tried a research lab, and I worked on a project and helped them carry it from beginning to end, and resulted in a publication. And I just wanted to see were all the areas of research you could do. And I mean, of course, you can't do them all. And it caused me also to fail some of my classes because I was very focused on doing research. But first year I worked on learning why bacteria, how they passed on their drug resistance with plasmid DNA. This is like one of the first labs for this. Then the next year, I isolated chondroitin sulfate, which is sold at Costco now to help arthritic knees. I worked on isolating and imaging RNA polymerase II. We never got to publication because it was really hard to isolate this stuff. Then I worked in a biology lab with fruit flies, and it was one of the first labs in the country to start building the DNA library. And my little sliver was to follow the role of 7 genes that coded for a cuticle protein that came onto the fruit flies' wings at a particular time during their development. And that's when I realized I probably don't want to study fruit flies, because I would mistime it, and we would be, the protein would be coming out at like 2 o'clock in the morning. We'd be racing across Chicago on our bicycles to get to the lab because that's when the cuticle protein happened. So I went into chemistry, and this was when lasers were still starting to be engineered. And under the guidance of a postdoc, I analyzed the spectral and temporal substructures of very short laser pulses, so that you can use these laser pulses then because now you can use laser pulses to monitor really fast events in chemical reactions. But every year something came out of this, which was published. And so finally I got to graduate, and I got with honors for doing the research part. Then I went to Stanford, and I got a PhD monitoring chemicals, small molecule reactions with Dick Zare, and I postdoced at University of Pittsburgh looking at the theoretical studies of these exact same reactions. And following that, I was a visiting scientist. I got a position at the Weizmann Institute for a few years. Again, a theoretical position. I returned to University of Pittsburgh, and I started a program looking at the condensed phase reactions of sulfur dioxide. And the reason why I wanted to look at them is because that means sulfur dioxide in water droplets, in other words, acid rain. And in order to pay for food and rent, I also worked. I taught a class at Pitt, I taught 4 classes at Chatham, and I taught a class at Penn State, New Kensington. Then I entered the high school. And in the high school, I have taught for 27 years. I've had a lot of students. I've taught on many grades, several grades and different classes and science fairs, science clubs. And now I get to why research. So I was a little stunned in high school that so much of a student's time is expected to be spent sitting in chairs, being quiet, regurgitating information. And I wanted my students to have a better appreciation for why they're there. And I wanted to teach research. I thought, we need to get these kids thinking. not just regurgitating. And so about 15 years ago, I started teaching research, but I did it more as a group, and then it eventually evolved into the classroom. What I've discovered at the very get-go is that I can't force kids to do chemistry and physics all the time. So, or biology as a plan B. Once I allow students to choose any topic of research, they get so passionate, they take ownership, they'll take us to the moon. So I have kids who are researching poetry, art, history, social science, economics. I have kids all over the map. And just for my own sanity, I try to limit it to 35. But kids are researching every aspect. It's once they realize that they can open any door they're curious about, these kids take off. The second thing I noticed about the kids is that no matter what area of research they're looking at, it dawns on all of us through the first semester how important math is. Whether they're looking at analyzing somebody's irregular heartbeats, or they're looking at an insect population or an economic growth chart, math is the center of everything. And it has become, through Mathematica and different modeling, math has become a universal language that we all share. So that's been really, really cool. And so I let kids just pick a topic and let's go with it. So I wanted to be able to take this into the school in a way that kind of matches the pedagogy of these kids that we're working with. The psychology of a teenager, we're all wondering what they're thinking, and it's crazy. And a number of people have asked me to pass on my curriculum, but it's not that easy. It's more of taking ideas and morphing them to the community that you work with. And in that way, I would be really excited if we could have a center, a resource center, where we could work together and mentor each other through this endeavor. I wanted to know how I could do this in the Pittsburgh Public Schools. So the first thing I did was I started attending workshops. I went to the International Leading Science Teachers Program at the Weizmann Institute, and I discovered that all around the world, governments have set up these frameworks for supporting research in the high school. I met the director of science education from Singapore. They set it all up already, and they did the same, and they've done the same in England and Germany. And I was like, wow, this is really cool. So I came back and I was working with the kids, and I started looking around, and I noticed that teachers from the state of New York do particularly well at ISEF, and other states too. But what is it about New York? So I started calling those teachers to find out. And I discovered there's a network, and there are resource centers. And so one of them is at the University of Albany. So I paid to go to a workshop. And I discovered that once you're part of the resource center, once you've gone through the training, once you start working in an official way with the resource center, they match your students up with mentors. They help you figure out pedagogy for your classroom. They make so much possible, but you have to sort of buy in. It's not just you drank the Kool-Aid, but you also have to go to particular workshops and become part of the center, which, I mean, if I was in New York, I would definitely be in this. And then I asked the school in Pittsburgh Public Schools if we could make this an AP course, because the parents were complaining the kids were doing so much work for nothing, no credit, that I said, well, let's make it an AP credit. And so the AP Summer Institutes are also super informative about how to teach research in your school. And they also have come to the conclusion that while there's some guiding principles, you can't just follow one script. It's got to be what works with your community. The next thing I did was I joined professional groups, and I highly recommend, and I'm putting these up here, and my slides are on the Carnegie site with Nikki. So if you need these ideas, they're there, and hopefully they're helpful to people. But this SSP Research Teachers Conference is amazing. You're required to participate. I've been there twice. They also have an Edmodo group, but I noticed there's other Edmodo groups for research teachers. And also the College Board has a College Board community, but there are Facebook groups for research teachers. There's all kinds of ways you want to interact with people, because it's like YouTube. You ask somebody, how do you set up this lesson? And somebody's got to tell you how they do it. I attended webinars. This is one of my favorite groups, is the Society for Science in the Public. It's an amazing group of people who set up all kinds of ideas to help teachers. And if I think I can go to that. If you look at their webpage, you can find they have webinars on anything, tips to apply for summer programs, how to keep student lab spaces in your school, guiding students through the paper writing process. This Society for Science in the Public makes it their business to help people learn how to be better teachers of research. So I really, I'm going to say, there's no better place. Well, I mean, no, maybe there will be in Pittsburgh. We're going to make it better here, but they're amazing. So I joined professional groups, webinars. Oh, and then I bought a lot of books. So the National Science Teachers Association has a ton of books. Here's 3 that I bought. And these books are amazing. They have inside of them, lessons, they have student worksheets, they have teacher advice to teachers, strategies for helping students learn how to write a procedure, how to come up with a research question. This writing science is good at all levels, from high school all the way through graduate school. And Joshua Schimmel has discussion questions on how to reflect on your writing. So I've used things for sure. These are my big 3 go-to books. But I really like them. I modify everything to fit my kids, but if you don't have time, like I know I have like 4 preps or 5 preps sometimes in teaching, I just take one of them and run with it. But I modify anything I use out of these, but these are amazing resources. So what I did over the past, say, 15 years is I've been slowly coming to grips with what works for my kids. Why research? I want my kids to feel like they're part of the community. I want them to get out of those chairs and to find the doorways that excite them the most. I had a student, he was just getting up and talking in class, and he stopped all of a sudden about 10 years ago, and he said, "You mean I can ask any question?" And I said, yeah. And just the look on his face, I thought, okay, I hope we go down the right road here. But you learn so many skills. And in my class, I'm not worrying about whether they're going to get a reward in a science fair. I just want them to start feeling an authentic experience. If they simply get the ability to interact professionally with people in an appropriate way, or if they just learn how to become more self-reliant, if they learn how to manage their time, we've made a huge impact on these kids. And they learn all kinds of stuff. I just listed a few things here. The hardest one for my students is receiving criticism and giving criticism. And I have to say, like, that's hard. If you were a student and you worked all night on a paper, the last thing you want is to be told, "That's great. Let's redo it." You know, and I'll make them redo things and their talks. But after a while, especially if they give a talk and one of their classmates critiques it, it's hard the first few months. And I have to say that by the time we're in the second semester, they're seeking out each other and asking for that criticism. They realize it's a sign of professional love, and that you want people to pull your arguments apart and to ask for evidence when you make claims. So they learn a lot of things that I don't think they learn in any other science class or any other class in high school. And these are skills that are valued in the world. So I'm going to share with you for a few minutes a few of the lessons that I do with my kids. This is my research class at Alderdice. Everything for me starts in the spring before the year begins. I make students interview for the opportunity to work with me. And again, I cut it off at 35 kids, but they have to make an interview. And I made this available as well to the interview. I thought it would be hyperlinked. All right, well, here it is. I made this available to the Science Center so they could put it out, but I make kids interview. I make them interview because I want to start opening those communication lines, and I want to start having a relationship with my students. And I want them to know what are they getting into, and I use this interview to find out what they're passionate about. Because when they come back and we go through the 30 minute to 1 hour interview, a lot of times the kids will be like, yeah, I said I wanted to work on this biology project, but I'm really into go-karts. I'm like, well, then why aren't we doing a project on go-karts? Like, what's the problem here? I'm really into stars. I really like to think about the stars. Well, let's do something related to stars. I really try to find out what are they excited about, because they're going to have to work on this the whole year. In the interview, I just look at what they wrote down for their essays. Who is your hero? Who's your favorite person? Tell me about a story on a family trip. I just try to get to know who this person is. Where do they see themselves in 5 years? But I also involve another classroom teacher. I discovered that every kid in our building has connected with one other adult, and it's not me. I'm new and out of the blue, but they've connected with somebody, and I try to bring that person into the discussion for the first month or two so that they're part of the interview and they're part of celebrating what this kid's decided to do and bringing them out a little bit. And that has helped a lot. It builds a community for this class. Then we're into the summer, all right? So in the summer, the goal, I don't know if I'm covering up part of the goal here with my picture. All right, well, it's not working. Yeah, I can't move it. I hope I'm not covering up the goal. In the summer, the goal is to develop a viable research question and to find an expert advisor. Of the kids that joined which is now a class for me, an AP class, but of the kids that joined the class, 40% want to do their own project on their own. They have an idea or they want to develop an idea. And that's perfect. I still try to help them find a mentor or an expert in our community, because I think Pittsburgh is a community that's filled with people who are experts, especially people who are just retired and want to still contribute. I definitely use any means I can to find people around us who want to talk to kids. But their goal, they have to make a question, and the question has to speak to a problem that they've noticed that they need to find an answer to. And they have to have a question that you can look at from many perspectives and know what are all the stakeholders on that problem that they're examining. 60% of the kids want to be in an authentic research lab. So half of those kids apply to summer programs, half search for their own mentor. So if we are searching for your mentor, they have to look on all the internet pages and it's interesting, kids have looked at the university's pages, and this summer I've had a number of kids looking at company web pages in the Pittsburgh area. And because I guess we have a lot of tech companies, especially in the area of robotics. So kids have been looking at different web pages and saying, well, I'm interested in this or this. And so they have to read papers that are related. Even if they don't understand them, they have to start walking through them. They have to start organizing their thoughts, and they have to craft a letter that I approve. So I have a contacting a mentor assignment. We walk through it. I add a paragraph at the bottom so that we're covered because of all the clearance stuff, and we send it together to a mentor. When I looked, before I leave this, I'm going to say about most of the research kids are proposing involves science, but there are other areas. All right, when I looked in Pittsburgh, there are tons of summer programs that are so amazing for kids and will support them working on projects. So we have the Hillman. David Boone is going to talk about that. This is David. And so we have the Hillman program. They put kids in actual labs working on research related to cancer. We have the Gene Team, which is run by Becky Gonda. And they also are working on projects that were set aside in research labs just for high school kids to work on. And I have kids in the Governor's School where they meet professors. And there is also the McGowan Institute has a tissue engineering program, which is like out of sight. So that's just the start. But if you go and you Google on the internet, you can find all kinds of opportunities for kids. There are opportunities elsewhere. I have had kids apply to the Science Research Institute, and the Rockefeller University program is just like UPCI. It's really amazing. And I've had kids, several kids actually get into the International Summer Science Institute at the Weitzman where they're doing authentic research. So all of these are ideas where kids can go off and actually find research experiences. And I don't know if it's just multiplying, but every state and every university seems to have some sort of program set up for high school kids. Okay, so that's our summer. Now we're into the school year. So in the school year in my class, there's 2 semesters. The first semester is becoming more familiar with your project, doing your research, and then everything builds for the second semester in which the student has to produce 3 products, the paper, the PowerPoint, and the poster. So the first semester, I make my students send to me a weekly update. Every Friday, they have to email me, what did they do that week? And what do they intend to do next week? And they have to CC their mentor. This keeps everybody communicating. It keeps us organized. If we see the student going in sort of a wrong direction, we can try to nudge them back. And it forces the students to start managing their time. I'm not there to force a student to do any of this. So if they mess up and they don't do this, if they fall in a hole, I let them. And interestingly, some really smart kids, valedictorians, have fallen in this hole. And I just let them look up and see that other kids are doing this. And I let them figure out how to get out of the hole, which is very uncomfortable for parents. But what I've discovered is a few years down the road, I'll get an email from the very same kids saying, I'm in college, I'm in a lab, I figured out how to manage my time. And so I feel like, okay, so this class served a purpose for them. I make the kids turn in annotated bibliographies, and they have a bunch of assignments. Every Tuesday, we meet as a group, and we do some formal classroom assignments that are going to help them get to their end goal. The mentor has expectations. I meet with the mentor. And they have to have clearances, have a system for meeting with the student, whether it's them or the students working under a graduate student or a postdoc, or the students outside of the lab and they're just going to Zoom with the mentor every other week, but there's got to be a system. They help out with helping me translate the Janet Vukatich, the IRB and the SRC forms, and they sign their contracts. The parents are super involved. I found out a few years ago that once I brought parents in, as if it was like soccer mom, all of a sudden they understood what their kid was doing. Before this, they thought, oh, this is just something at the school. This is Waldeck, she'll take care of it. And I would find myself on the phone with parents like the night before a science fair. Your kid didn't turn in this form, or I haven't seen their poster yet. And the parent would say, what science fair? And even though they had signed all the forms, somehow they forgot already. So I started requiring parents to have a meeting with me if they want their kid to be in the class. and the parents have to sign up, and they serve. I figured if they can sign up and help out at basketball games, they can do this for their research class. So they serve on panels, they help out with the research symposium, and if they can't come, a grandparent can come, or an older brother or sister can do it, or a neighbor can do it, but they all contribute to running the class, and they have little things throughout the year that they do. And then I meet with all the students, the mentors. I keep folders of everything, the clearances. I submit everything to their competitions. I created a district-wide research symposium, guide the students I have student-teacher meetings throughout the week to help students navigate the human interaction of being in a lab. And I provide the structured curriculum every Tuesday that we meet that helps them develop their sense of communication. So in the classroom, this one meeting a week, we go through a set of scaffolded activities that get us to the 3 final products. And the way I look at it is I think of this as pieces of a puzzle. So if I think, oh, well, they need to be able to generate a really good research question, then I take them to the research question gallery walk, which is included in what I submitted to Nikki. And in this case, we go through the formal introduction of how a research question is a question you generate because you know about a problem that exists and you want to figure it out. But then I have the kids write their question at the top of a butcher block paper, and then everybody walks around with a marker and writes their own questions about that question, like, well, how much time is it going to take for you to get all this data? Or what do all those words mean? Or, things like that, and why is this research question important? And the following week, everybody does a 5-minute presentation, kind of owning up to why their question was answering the concerns that their classmates had, and trying to say, well, this is important because, and interestingly, a lot of kids will change or modify their question once people start asking. So I go through all different ideas. I've included them in the packet for that I submitted for this workshop. I'll go real quick. We have a news article presentation. I have kids read news, like actually I put science news for students, but actually I changed it this year, and I'm just having them read news out of Time magazine or, The Atlantic monthly, and say, where did your topic come up? And tell us about what, in a broad way about your topic and what's interesting. When I ask kids to write their procedures for the science fairs, they have a lot of trouble. So I have the peanut butter and jelly approach that I got from a person at Pitt. He said, have them make a peanut butter sandwich. Have them tell you the procedure for making a peanut butter sandwich, and then follow their procedure in front of them, and they will be hysterical. They'll laugh. I have students, I make up credibility games. So when students go to the library and they're pulling out research articles or any article to read, we go through all of the points of what makes a credible article. And actually, we usually turn this one into a game that's fun to play. And the last is just another piece. There's another go-to person who's not here today, and that's Caitlin Sullivan. And I put a site on here. So if you go to this PowerPoint, it's nice to go to her site and see this. She's a master at coming up with other ideas for getting kids excited to start thinking about questions. And she said she has this PowerPoint that she put on here, a webinar on the fact that kids are naturally curious, and how can we tap into that in strategies for getting kids to start being the ones that ask the questions that they're excited about. But for time, I'm gonna go forward and just get to the end. Whoop, what am I doing? Here we are. All right, so once all that's happened, the next thing I did in my high school is I try to get my class kind of integrated into the fabric of the school. You know, it has to be as much of a part of the school as the basketball team or the school musical. It's got to be something that is for everybody. So I try to develop a community by bringing in people that are older and younger than the kids in my classroom. I have my students volunteer at elementary and middle school science events, actually talk with the kids. I have classroom visits, people at all different ages. I try to help plan the BSU meeting, the STEMism meeting, the science club meetings, and I started the symposium. And it's really important to make your class part of this school culture. And Chuck should keep his ears closed, because the very first year was many years ago, like 12 years ago, we got a check from the Society for Science and the Public for $2,000 for kids doing research. And the school didn't know we had research. And I think the check went to the football team. But now we get all the checks. All right, so I try to think long term and try to build this class into this entire school. And what I do to that is I try to find kids that are in 10th grade and try to work with them. I flag them down in the hallway and work with them over a 3-year period. I advise them on the classes that fit their passions. I try to get to know them and keep their parents in as part of the program. And if I see any kind of outreach or enrichment, I try to make sure they know about it. The next thing I do is I volunteer like crazy in Pittsburgh. I get to know all the program directors. Anything my students have participated in, I know the director and I can email them, but I also volunteer in order to advocate for them. So I'm on the board of directors for the PJS Region 7. I've helped out with the judging as much as they let me for the middle school, so there's no conflict of interest at pre-CEF. And I'm on the local arrangements committee for ISEF. So I try to get involved. I try to write letters of support when they need program funding, and try to make sure that there's a pipeline, especially for the underserved kids, to get into these programs. Once it's all said and done, I try to get the last 9 weeks of the school year is icing on the cake. We try to get kids out the door as much as possible to present all of their work in Pittsburgh or beyond. So these are the venues that I bring them to. Also, I ask the expert advisors if they know of any professional meetings, and that has been pretty interesting. So some of the kids have presented at professional meetings. So with David Boone's UPCI, they already just took 2 of the kids to the IEEE conference on health informatics. But there was a student in my class who presented at the McGee Women's Research Summit last year or the year before. I've had 2 students present for them at the American Association of Toxicology conference, and I actually had 2 students fly to San Diego to give a poster at the American Cell Biology conference several years ago. And it turns out that a lot of professional organizations have poster sessions and have money earmarked for high school students to present. And so that's really, a carrot to dangle and say, that you've done this really great work. This is good. And lastly, I try to get students to, once they've gotten far enough in their project, to start considering submitting their project to a high school research journal. There are a lot of them out there. This is only a small list, but if you Google high school research journals, they're all over the place. They're excellent. And it's a way for the student to develop their writing skills and to kind of develop a way of finding your own voice and not just parroting back what everybody in the lab was saying when they were doing their projects. So it's a nice way to end the year for them. All right, and there's my acknowledgements. And I thank you so much. No questions or interruptions?
Thank you, Jan. And I put the files you were referring to while you were talking in the chat. I will post them on our website